Okay, so we're going to find all the zeros. We're going to combine everything that we've done so far. So we're going to factor, we're going to quadratic formula, we're going to do long division, but we're going to find all the zeros. So that means we're going to find all the zeros that are real. Guess I need real and imaginary. And so if we have a trinomial of the form ax squared plus bx plus c, you want to try to factor first or use quadratic formula. If you have a 4-term polynomial, you want to try to factor by grouping first. Sometimes it doesn't work. And then if you've got a 5 or more term polynomial, there's really no way that we have learned to factor it. There's not an easy way. And so what you want to do is get a zero from graphing calculator and then do your long division. Or depending on the instructions, you can just find all of your real zeros from the calculator, but then you've got to make sure that you have all of your imaginary zeros as well. So remember, the highest degree tells you the number of zeros that you're looking for. And there are all these algorithms and other things that you can look at, your signs, and you can figure out how many real and how many imaginary. We're not going to look into that. We're just going to use this basic rule that the highest degree is going to tell you the number of zeros that you're looking for. So we'll just jump straight into an example. And so the instructions are to write the equation as a product of factors and list your zeros. So first example, we've got a function x cubed plus 4x. So in the end, we know that we should have at least 3 zeros. Real and imaginary, all real, all imaginary, whatever, it doesn't matter. So we've got a 2-term polynomial. We always want to see if we can factor first. And so this one, we can take out an x. That leaves me with an x squared plus 4. Already factored, x squared plus 4 doesn't go any further, so we'll set both of those equal to 0. And we will solve. So when we take the square root of -4, that's the same thing as saying the square root of -1 times the square root of 4. But by definition, I is the square root of -1. And so if square root of 4 is 2, x ends up being plus or minus 2i. Hopefully that's not new. That's a Math 2 concept. So when we write it as factors, we've got one factor that's x. We've got one that's positive 2i and one that is a negative 2i. Remember, the factors are what you set equal to 0. And then my zeros would be 0 and plus or minus 2i. So we end up getting 3. We are good to go. All right, so the next one, we've got a function, same instructions, write it in factored form and list out all your zeros. We've got x to the 5th plus x to the 3rd plus 2x squared minus 12x plus 8. And so we've got 5 terms. We don't know how to factor that, so we are going to graph it. So go ahead on your computer, on your cell phone, graph that function using Desmos. It's the easiest. And I'm going to sketch it. So we see that it looks like a cubic function, which makes sense because it's to the 5th. So it's an odd function that has that same shape. And we see that we have a 0 at -2, and it crosses, so that means it's an odd multiplicity. And we have a 0 at 1, and it bounces, so we know it's even. So using as much algebra as we can, what we're going to do is take that -2, it's odd, so we can assume it happens once. We can write out the factor, so we know x plus 2, and we're going to do long division with my original function. So it's a good review of long division if you're still a little bit uncomfortable with that. So x times what gives me x to the 5th? Well, x to the 4th. And so if you'll notice, I'm missing a term. So we got to back it up and put in our missing term. Ideally, you would catch that before you write out everything. All right, so x times x to the 4th gives me x to the 5th. Multiply, draw my line, and subtract. When I subtract, I've got opposite signs. My first term cancels out. 0 minus 2x to the 4th is a -2x to the 4th. Bring my next term down. So then I've got to figure out what multiplied by x gives me a -2x to the 4th. That would be a -2x to the 3rd. Multiply it out, so -2x to the 3rd times x gives me a -2x to the 4th. -2x to the 3rd times 2 gives me a -4x to the 3rd. Draw my line and subtract. When I subtract, all those signs are opposite, and my first term should cancel. So now I've got x cubed plus 4x to the 3rd. That gives me a 5x to the 3rd. Bring down my next term. X times what gives me 5x to the 3rd? Well, that would be a 5x squared. Go ahead and multiply. Draw your line and subtract. First term cancels out. And so now we've got 2x squared minus a 10x squared gives me a -8x. Bring my next term down. X times what gives me a -8x squared? Well, that would be a -8x. And then we'll multiply. So -8x times x, -8x squared. -8x times 2 gives me a -16x. Draw my line, subtract. Flip those signs. My first term cancels. -12x plus 16x gives me a 4x. Bring my 8 down. All right, x times what gives me 4x? Well, that would be a 4. 4 times x is 4x. 4 times 2 is 8. We see that everything cancels. My remainder is 0. So we know that x plus 2 is a factor, which we already know because of the graph. And so then we're going to take that quotient and divide it by the other factor that we know. And hopefully when we divide it one more time, we'll get 4 terms, and we should be able to factor by grouping. So x to the 4th minus 2x to the 3rd plus 5x squared minus 8x plus 4. So on tests and quizzes, if you don't get a remainder of 0 and you know that it should be a factor, you've messed up somewhere in your long division. So you'll have to go back and check. So just be really careful there. All right, x times what? It gives me x to the 4th. X to the 3rd. X to the 3rd times x is x to the 4th. X to the 3rd times a -1 is a -x cubed. Draw your line and subtract. When we subtract, all those signs are opposite. My first term should cancel, and then we'll subtract. So -2x cubed plus x cubed gives me a -x cubed. Bring down my next term. All right, x times what gives me a -x cubed? That would be a -x squared. X squared times x gives me x cubed. Negative x squared times a -1 gives me a positive x squared. Draw my line and subtract. My first term cancels out. And we've got 5x squared minus x squared gives me a positive 4x squared. Bring my minus 8x down. All right, x times what gives me 4x squared? Well, x times 4x. Multiply by both of those terms. Draw your line and subtract. Opposite signs. First term cancels out. Negative 8x plus 4x gives me a negative 4x. Bring my last term down. So x times what gives me a negative 4x? That would be a negative 4. And so I've got negative 4 times x, negative 4 times negative 1. Draw my line and subtract. They are the same. When we subtract, we will get a remainder of 0, which still makes sense because we know that x minus 1 is a factor, because we know that 1 is a 0, because we know about the graph. So far my factors are x plus 2 and x minus 1. Because x minus 1 is even, we know it occurs at least twice. And we know that in the end we're supposed to have at least 5 zeros. So now we've got x cubed minus x squared plus 4x minus 4. And so we've got a 4-term polynomial, so we're going to see if we can factor it by grouping. So we'll put our first two together, our last two together, take out a GCF, and see if this will work for us. So we've got here, put my outside stuff together, my stuff that repeats one more time. And so even without really thinking about it, we see that x minus 1 is repeated without even having to do another long division. All right, so if we've got factored form, we know that x squared plus 4, we already know its factors to x plus 2i and x minus 2i. We did that in the first example, so I'm not going to do that again. So we've got x squared plus 4 times x minus 1. We know that it occurs twice. And we know that x plus 2 occurs once. So we've got 1, 2, 3, 4, 5. So x squared tells me I've got 2. So really the full factored form would be x plus 2i, x minus 2i, x minus 1 squared times x plus 2. And so also my zeros, if we list them out, would be plus or minus 2i, 1, and negative 2. When you list out that 1, go ahead and notate that it's a double root. You know that it occurs twice. All right, so we have in the past made the assumption, we know that irrational roots, so stuff underneath the radical sign, come in pairs. So now we're going to say complex numbers also come in pairs. So 2i, there's a positive 2i and a negative 2i. So complex and irrational roots come in pairs or groups of 2. So we know that if we are given the 0, 1 plus root 2, we can assume we also have the root 1 minus root 2. Same thing with complex. So 1 plus 3i, we assume that we also have 1 minus 3i. I don't know why I put that underneath a radical. Whoop. Did it over here too. Okay. And they're called conjugate pairs because the only thing that's different is the sign. So last example we're going to do, and then you get to practice it a lot with homework. So given 1 plus 3i is a 0, of the function so x to the fourth minus 3x cubed plus 6x squared plus 2x minus 60, we are going to find all the factors and zeros. So when you are given an imaginary root, you want to take out that first. You want to deal with it first. So if we know that 1, 0 is 1 plus 3i, we know that a second one is 1 minus 3i. So in the past, what we've done is we are given zeros and you have to write a polynomial. So now we're going to apply that in this problem. We are given these zeros. We are going to use them to create a polynomial. And so we're going to multiply this imaginary stuff first. And so I've shown you two ways to do this. You can either do it by your a squared minus b squared, or you can do it by drawing the box. I'll show you both of them again just so you can see it with complex numbers, not just irrational. So the first thing is, if we've got a squared minus b squared, we know that it factors to a minus b, a plus b. So we've got the factored form, so we're trying to figure out a squared minus b squared, which would be x minus 1 squared minus 3i squared. So if we FOIL out the x minus 1 squared, we've got x squared minus 2x plus 1, 3i squared. We square both terms, so we've got 3 squared, which is 9, and I squared, which is negative 1. And so we end up getting a plus 9. And so we get x squared minus 2x plus 10. So I'll show you by the box method too. X minus 1 minus 3i, x minus 1 plus 3i. And you can choose either one. So where your columns and rows overlap is where you'll multiply. And after doing this, you should find that all of your complex stuff goes away. All right, so negative 9i squared is the same thing as negative 9 times negative 1, which is a positive 9. All right. Mark out some stuff. We know that negative 3i and 3i cancel, 3ix and negative 3ix cancel, and my 9 is simplified there. So either way, you should get x squared minus 2x plus 10. Using that function, because you already know that they are factors, we are going to divide by our original function. So I'm going to scroll down a little bit. Using that x squared minus 2x plus 10, we're using that as a divisor from our original function. And we should be done with the complex roots from there. Make sure your dividend is in descending order and you're not missing anything. And then we'll multiply. So we've got x squared times what gives me x to the fourth? Well, that would be an x squared. So x squared times x squared is x to the fourth. X squared times a negative 2x is a negative 2x cubed. And x squared times 10 is a positive 10x squared. Draw your line and subtract. When you subtract, all of your signs are opposite. First term should cancel, and then we will subtract the rest of the way down. So negative 3x cubed plus 2x cubed is a negative, and then 6 minus 10x squared is a minus 4x squared. Bring down your next term. All right, x squared times what gives me a negative x cubed? Well, that would be a minus x. So you've got a minus x cubed plus 2x squared minus 10x, draw our line, subtract, change all the signs. First term should cancel. Bring that negative 60 down after we subtract. All right, so negative 4x squared minus 2x squared. 2x plus 10x is a 12x minus 60. All right, x squared times what gives me negative 6x squared? Well, that would be a negative 6. And then we will multiply that negative 6 by our divisor. And what do you know? All of those things are the same. They cancel. My remainder is 0. So we know that x squared minus 2x plus 10 is a factor, which means we know both of those imaginary roots are a factor. And everything is working out nicely. So on tests and quizzes, if things aren't working out nicely, know that you made a mistake somewhere. So you're going to have to redo that long division and see if you can catch your mistake. Once we have it down to a quadratic, we want to see if it factors further. So already we have factors of x, I want to make sure I remember, x minus 1 minus 3i, and x minus 1 plus 3i. That gives me that x squared minus 2x plus 10, x squared minus x minus 6. If it factors further, I need to simplify it all the way. And so I know that the numbers that multiply to give me negative 6 but add to give me negative 1 are a negative 3 and a positive 2. So then you want to go back and check. Well, I've got 1, 2, 3, 4 factors. They're each occurring once. My highest degree is 4. I've got all of the factors. And then I've got to list out all of my zeros to fully answer the question. So your zeros would be 1 plus or minus 3i, positive 3, and a negative 2. So we're kind of putting it all together. So those were 3 quick examples, finding all zeros. Make sure that you get this pretty well because your quiz will deal with that and your test will deal with that. It's a little bit time consuming, but just make sure that you are following the procedure. Make sure that you understand. Make sure that you understand that you can check yourself with the graph. Your graph only shows you the real numbers and we are finding all the zeros.